Hello dear students. So today we are going to study Gauss law, one of the important laws in electrostatics. So before we study Gauss law, let us recall what we have studied in the previous class. So we have studied electric flux. Electric flux is nothing but the total number of electric field lines passing normal to the surface, or the field lines which are perpendicular to the surface. That was the electric flux. Now Gauss law also helps us to find the electric flux. Now most of you might be wondering why we need to study Gauss law when we have a ready-made formula for electric flux, which is phi is equal to E delta S or EA cos theta, as simple as that. But Gauss law makes your life much more easier. He has given a very simple formula to find the flux of any three-dimensional object. So instead of using any complicated mathematics or any integration terms, he has just given one simple formula that will help you to find the flux of any complex body. So Gauss law will help us to understand the electric flux in simpler way. So before we study Gauss law, write the statement along with me. So since it's a law, you should not modify the statement. You are expected to write as it is. So Gauss law states that the total electric flux, you can write along with me, the total electric flux through a closed, the closed word is very important, through a closed imaginary surface in a free space is equal to 1 upon epsilon naught times the net charge enclosed by the closed surface. So don't modify the statement, write as it is, since it's a law. So don't modify any statement. So try to understand what he is telling. The total electric flux, all of you know what is the formula for electric flux. The other day only we have derived it. Phi is equal to E delta S or EA cos theta, meaning remains same. Okay, don't go with the denotions. Fine. So what Gauss is telling you is the total electric flux through a closed imaginary surface in a free space is equal to 1 upon epsilon times the net charge enclosed by that surface. So now one condition is, for Gauss law, the surface should be closed, and the Gauss law is valid only for three-dimensional objects. If it is sphere, cube, or cylinder, or what is that, conical cylinder or triangle, Gauss law is only valid for 3D objects. Only valid for 3D objects like cube, cylinder, sphere, okay, hemisphere, etc. And the surface should be closed. Okay, the surface should be closed, and surface enclosed is also known as Gaussian surface. So surface enclosed by the conductor is also known as Gaussian surface. Okay, we'll come back to the conditions afterwards, where and how it is valid and what are the applications. But let us understand the law. So what it is telling you, suppose I have a closed surface, and in that closed surface I have n number of charges, plus q1 plus q2 minus q3 plus q4 minus q5 and so on. So the total electric flux, now you tell me, since every charge will give rise to certain electric field, yes or no, and electric field will obviously give you electric field lines, which is a imaginary concept which tells you the strength of the electric field. So q1 will have its own electric field, q5 will have its own electric field as well as own electric field lines. So similarly, this is a closed surface, a 3D surface. Imagine a cube or any three-dimensional object, and these are the charges enclosed in that surface. Now these charges will give you electric field as well as over a particular area. So those electric field will also tell you its electric field strength by its electric field lines. So field lines crossing normal to this surface area will give you flux. Yes or no? Now let us apply this using Gauss law. So what he is telling, the total electric flux, all of you know what is formula for phi? Phi is equal to, through a closed imaginary surface, suppose the surface is not closed, we will take certain part of that object and we will assume that it is closed. I will tell you how and what is imaginary surface as we go deeper into the concept. Let us understand step by step. In a free space is equal to 1 upon epsilon naught times 1 upon epsilon naught times the net charge enclosed by the closed surface. So net charge or the total charge enclosed by this closed surface. So what is the total charge? Q1 plus Q2 plus minus Q3 plus Q4 plus of minus Q5. Yes or no? So total charge or the total net charge enclosed by the closed surface. So this will be what? 1 upon epsilon naught times Q1 plus Q2 minus Q3 plus Q4 minus Q5. Just to put it to the words. So what will be this? Phi is equal to 1 upon epsilon naught times the net charge. The net charge. Are you understanding? So this is what a Gauss law means. See here, simple formula, nothing complicated. You take any body and if I ask you what is the flux in that body, any body in the sense three-dimensional object, okay? I'll tell you when we study applications how actually it works. Simply you have to get the net charge divided by epsilon naught, where epsilon naught is permittivity of the free space whose value is supposed to be 8.854 into 10 to the power minus 12 Newton meter square per Coulomb square. Just verify with the SI unit, okay? I may be wrong here, okay? Just verify this. So where epsilon naught is the permittivity of the free space. Are you understanding? So Gauss law makes your life very easy. If you want to find the flux, simply get the net charge divided by epsilon naught times, that will get you phi. Are you understanding? So now we have got two formulas for phi. So one formula is our EA cos theta and the another one is this formula. So as per our requirement, we are going to use both the formulas. Are you understanding? So now let us prove Gauss law. Remember two conditions as I told you. The surface should be closed and that closed surface is known as a Gaussian surface. Second most important thing, it is only valid for 3D objects. Now remember one more thing. This Gauss law is independent of size and shape of the body. Look somewhere. Have I introduced any dimensions of that closed body? Have I considered a radius or thickness or length or diameter? Nothing. I am just interested to find the net charge divided by epsilon naught times. That will get me what? Flux. So let us prove this law actually. Okay. Have you understood this? So this statement and this simple explanation that they may ask you for 2 marks in the exam. Okay. No. Okay. Shall I erase this? Now, let us prove Gauss law actually. Okay. So remember the conditions. Closed surface which is known as a Gaussian surface. It can be an imaginary surface. We need to imagine at certain point of time, okay, where the problem gets complicated. Okay, now let us prove it. Proof. Actually, it's not a direct proof, but just to make you understand, try to understand this. Suppose I have a sphere. And the charge should be inside that body, okay? Whatever charge is enclosed, that should be inside the body, okay? So see here, this is the radius, this is my sphere, okay, spherical body, and let R be the radius, okay, and this O be the center, and at O there is my charge enclosed plus Q. Okay, now this is not a closed body. It's a closed body, but what we are going to do is we will consider a imaginary Gaussian surface. We will consider this portion of that sphere. Okay, a very small portion actually. Assume that I have magnified that image. It is very small portion of this sphere. So here makes an angle theta. Okay, here I get an angle theta. So since it's a sphere, I am going to get this enclosed portion. Now you know that this is the surface of that sphere. So where will be its radius vector? Obviously perpendicular, dA. And since it is a plus charge, its electric field lines will be always directed radially outward. So electric field is also in this direction, and my the area enclosed by the sphere is also directed radially outwards, since it's a aerial vector what we have studied in the previous class. Have you understood this? So this is the consideration to prove the Gauss law. Consider a sphere, let O be the center, let R be the radius of that sphere. Consider a Gaussian surface. Now this surface which I have made it bold or little bit darker. This surface is called as a Gaussian surface. So of that Gaussian surface, I have considered a small area dA. Okay, small area dA, and its electric field lines are directed radially outwards. Okay, they are directed radially outwards. Now, for a small surface area dA, you have to write a consideration for this, okay, and draw a neat diagram. Okay, so for a small surface area dA, I am going to get small flux. Yes or no? See, we will find total flux afterwards. Let us find what is the electric flux at this point or at this Gaussian surface. So for small surface area dA, I am going to get a small flux d phi. Is it not? Then later and later I am going to get at different points, and then simply I'll integrate it, or I'll simply do the summation, and I'm going to get the total flux. So d phi will be what? D phi will be E dA cos theta. Is it not? That's the simple formula. Got it? Okay. So dA is the small surface area, and E. Now E will not change because E is always directed radial outwards, and E will throughout the surface will be same. You have studied that in electric field lines, and which is normal to the surface of the conductor as well as along with the area vector. Okay. So here, since E and dA are directed along the same line, so in this case I will get theta as 0 degree. Is it not? The other day only we have studied this. If they are along the same line, if they are along the same direction, so in that case theta will be 0 degree. So if theta is 0 degree, all of you know that, sorry, not 0 degree, it's perpendicular. It will be perpendicular, right? It will be perpendicular to the surface of the conductor. Yes or no? Okay. But these dA and E are along the same line. So here I am taking theta as 0 degree. Okay, don't confuse yourself. Okay, the electric field lines and dA are perpendicular to the surface. It's proved. Okay, but the angle made by E and dA in the same direction will be 0 degree. Are you understanding? E and dA are in the same direction. So we know that cos 0 degree is equal to 1. Is it clear this point? Okay, you need not write this in exam directly. You can write cos 0 as 1 degree. Have you understood? Okay, so now I substitute d phi will be equals to what? E dA. Yes or no? Cos 0 will be 1. Cos 0 will be 1. Okay, now total electric flux. Total electric flux over the sphere. So this way I'll go on continuing. I'll take this surface area, I'll take this surface area, I'll take this surface area, I'll take this surface area. So if I go on doing this, I'm going to get a d5 here, I'm going to get d5 here, I'm going to get d5 here. Because from center you draw any line to the surface, that will be radius r. Is it not? Got it? So this way I'm going to get d5, 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 d5 everywhere. So when I do d phi, d phi, d phi everywhere, I am going to get total d phi, that is total electric flux. When I add all this, I am going to get what? Total electric flux. So total electric flux will be phi. So phi will be what? E. dA will be what? Summation of dA. I hope you know what is meaning of summation. Summation means just adding up the things. So what is changing here? Every time dA, 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 dA is changing. Surface area is changing. So when you do dA, 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 all the dA, you are going to get total surface area of the sphere. Is it not? Got it? So we know that total surface area of the sphere will be what? Total surface area of this sphere will be 4 pi r square, right? Are you understanding? So here you can write dA. dA will give you total surface area A, which is equal to 4 pi r square. Got it? So this dA, or you can write one more step here if you want. So phi will be equals to what? E A. E A. This is actually area vector. Okay. So here will be what? Phi equals to E 4 pi r square. Now you can give it as equation number 1. Have you understood this? So this dA, summation of this, summation of dA gave you A. Some total electric flux d phi gave you what? Phi. Is it not? Okay. Now we know that. I'll erase this part. Okay. Now we know that what is the formula for electric field? Electric field is nothing but what? 1 upon 4 pi epsilon naught q divided by r square. Yes or no? Electric field formula. Electric field formula is 1 upon 4 pi epsilon naught q by r square. Yes, is it not clear? So if you have not watched the previous videos of electric field, then you will not understand this. So electric field is nothing but force experienced by that charge at any point. So electric field is given by 1 upon 4 pi epsilon naught q by r square. So this value of electric field I have substituted here. So instead of writing E, I have written 1 upon 4 pi epsilon naught q by r square into 4 pi r square. 4 pi r square. Now look carefully. Can I cut 4 pi with 4 pi? Also can I cut r square with r square? Yes. So what do I get here is? I get here is 1 upon epsilon naught times the net charge. This is the total charge. Net charge. No, we have done summation. So equation number 2. So this is what the proof of Gauss law. A very simple law. Okay. Why it has its own importance? Because you need not do any complicated mathematics. See here, look carefully. The Gauss law is not depending upon the dimensions of the object. It is not depending upon the shape of the object. I'll give an example. Okay. Now see here, after proof, it is clear that nowhere r is involved, no size is involved, no shape is involved. So it is independent of this. I'll just give an example. If I increase this radius, for an example, if I make it 4 times of r, I'll make this 4 times of r. Obviously, so initially the radius which was r, now it became 4 times of r. So here radius, since radius is increased, what is your assumption? Will flux will increase? What is your opinion? I have increased the radius, charge magnitude is same, just I have increased the surface area. What will happen to the flux? According to Gauss law, flux should not change. So let us substitute and see here. I think most of the thing will remain same. Only instead of this r square, I will get here 4r square. 4 times r square, right? And here also I am going to get what? 4 times r square. So still 4r square get cancel. And at the end still I get this. So is it clear now? Gauss law does not depend upon the dimensions of the object, nor the size, nor the shape. And also it does not depend upon shape also, okay? Because the electric field lines are directed radial outwards, which is along the area vector only. So it does not depend upon the shape also. Got it? Have you understood this? Okay. Now if I ask you one question, what is the this is all about the Gauss law, okay? So in the next class we will be studying the applications of the Gauss law. Okay, so try to make Gauss law perfect today itself, so that whenever you attend the next class, things will become very easier to you. So probably 2 more classes, then this topic will get over, wherein we are just going to study the applications of the Gauss law. Okay. Can you tell me, find total electric flux enclosed by an electric dipole. You can pause the video and try to solve this. You can pause the video and try to solve this. Come on. What they are asking is, find the total electric flux enclosed by an electric dipole. All of you know what is an electric dipole. It is nothing but a system of equal and opposite charges. Equal in magnitude but opposite in polarity, separated by certain distance, is known as a dipole. Is it not a dipole if I have plus q here, if this is minus q separated by a distance 2a? Is it not a dipole? System of equal and opposite charges separated by certain distance is called as dipole, and P will give you q, to A will give you electric dipole moment. So can you find electric flux enclosed by an electric dipole? Come on, by using Gauss law. See here, you need not worry what is the length. What Gauss law tells you, flux is equal to 1 upon epsilon naught times the net charge. So what is the net charge? I have plus q here, and on the other side I have one more minus q here. So this will be minus q. So phi will be what? 1 upon epsilon naught times q, plus minus will become minus q will be what? 0. So flux will be what? 0, because q minus q is 0, 0 and anything will be 0. Are you understanding? Okay. Is that clear? So see here, very easy to understand. You need not worry about the dimensions. Just get the net charge and divide by epsilon naught. Try to solve one more. A cube encloses a charge of 1 coulomb. Find the total electric flux. Find the total electric flux. You can pause the video and try to solve this. I have a cube. In that cube there is one charge of magnitude 1 coulomb. What is the total electric flux? Come on, try to find it using Gauss law. Simple. What is the solution? Flux. We need to find flux. Flux enclosed by this cube. See here, as I told you, cube, all of you know what is a cube. So here somewhere charge is enclosed inside that cube, and that charge will give you electric field lines which is perpendicular to the aerial vector, or it may not be also. Those lines passing normal to the conductor are called as electric flux. So by using Gauss law, it's a closed surface. So phi will be what? 1 upon epsilon times the net charge. So phi will be what? Cube encloses charge of 1 coulomb. So 1 coulomb is what? 1 divided by, Q is 1 coulomb, right? 8.854 into 10 to the power minus 12. So find this answer. 1 divided by 8.854 into 1. Even I try to calculate with the help of calculator. So I got answer something called as 1.129 into 10 to the power minus 11. And what was the SI unit of this? Newton per coulomb meter square. So yesterday only we have seen the SI unit also. Got it? 1.129 into 10 to the power minus 11 Newton per coulomb. Have you understood? Okay. We'll try to solve one more problem. Very simple problems will appear in the exam from Gauss law. Third, a charge is placed at the center of the cube. What will happen? What will happen to the electric flux if the charge is moved at a distance of center of sphere will take, because we'll consider the radius. What will happen, flux, if the charge is moved at a distance of r by 2 meters. Come on, try to find. I have a charge which is enclosed in a sphere. It is giving you certain electric flux. The same charge is moved at a distance of r by 2. I think they have not mentioned whether the distance is increased or decreased. Assume that charge has moved somewhere. How much it has moved at a distance r by 2. So charge was here r. So now it has moved inside towards. So the distance became r by 2. What is the change in the flux? Come on, try to answer. So change in flux will be 0. We have seen from the Gauss law, Gauss law does not depend upon the value of R, D, L, anything. It does not depend upon the dimensions. So in this case, the answer is straight away 0. Don't use your brilliant ideas to solve this. Okay, don't do integrate or any complicated mathematics and still end up with getting a wrong answer. So sometimes you have to be smart enough to seek the answer very easily. So Gauss law helps you to get the answers very easily. If any question related to flux, if it is not coming by the traditional way, simply apply the Gauss law, you will get the answer in fraction of seconds. Okay, would you like to try one more? A cylinder. You take this as a homework, okay? A cylinder encloses a charge of 3.8 microcoulomb. Find the total electric flux. Now this is for your homework, okay? Everybody should write the answer in the comment section. Okay, I want the right answer for this. I have a cylinder, and in that cylinder there is one 3.8 microcoulomb charge enclosed into it. Find the total electric flux. Okay, so have you understood today's class? We'll stop it here itself. So next class we will be studying the applications of the Gauss laws, okay, which will be very interesting. So that will end your topic, okay, so that we can start next topic, that is electric potential and capacitor. So don't forget to mention your answer in the comment section. Okay, you need to tell me what is the total electric flux. Okay, so we'll stop. We'll meet in the next class.